Before we go further, let's just check the survey, okay? What do you expect to gain from this course? So here you can see, since it's a multiple choices, 80% learn data analysis and machine learning tools. Yeah. So here that is almost 90% hope that, right? So in this way, so we will focus on more on like fundamental, the traditional machine learning, transfer learning, and possibly like large model tuning. Okay. So because here we have 19%. And next one, master practical program skills. So this one, 70%. Yeah, this one looks weird because quite a few students think that they have good training skills. So for the remaining students, we try to use Colab and Python. And next one, gain theoretical knowledge. Here, 60%. So you see, this one will show quite a few. So we will like for the statistical inference part, we give you a systematic introduction and the question training. Besides for machine learning part, we also show you like the knowledge, algorithm, and the question practicing. And complete the capstone projects, 50%. Yeah, this one reasonable. You see, for this course, roughly just like 4 people will have a capstone project. Yeah, why do we say it's a capstone project? That means you learn something, you have a data set, you try to analyze the data sets, right? You download a cargo data set, you tell a story. This is our group project. So here, I like this, your answers here, okay? This one shows you have a strong meaning to learn and you know what's your inclination. And then next one, yeah. Next one, just like, what is your main motivation for taking this course? So here, this course is important for our future. Yeah, when I look at this answer here, I actually feel the responsibility. Yeah, I hope that our teaching team can give you a good experience. And if you feel we can do something, just like email me, email our tutors, or WeChat us, okay? So we will try to do more. Yeah, propel job interview. Yeah, this is important. You should know something. When people mention something, you can follow up. Yeah, this is important. So for some others, like just yeah, you need to take a course, right? What is your post-graduation plan? 70% just like go to the job market. So that means you want to become a data scientist. Here, I just want to remind you guys, I mean, lots only to become a data scientist. You may consider, for example, in Hong Kong, yeah, you know, currently there are a lot of shortage. For example, the teachers in primary school, in middle school. So see whether you may have some other educational diploma and find a job in Hong Kong. The salary is relatively high, right? So I mean, when you go to markets, let's only focus on the industries. You may consider the schools, the governments, and etc. Yeah, yeah. Try here to learn more. Okay. Next one, like the collab. So for Google Colab, here, no lots for million occupies 50%. But right now, I trust you guys have good training from Sijian, okay? Yeah, he prepared the tutorials very well. And next one, heard of it, but never used. So you see, here we have 90% students who are not familiar with Colab. But right now, I suppose you guys can. If you still have problem, try to learn from the tutorial Zoom, right? If still problem, then find us to see what we can help. Okay. Next one, like coding skills, overall program skills. If you look at this one, you see intermediates. Yeah, you guys are confident with yourself, 44%. Yeah, that's good. Good signal. And also 32 basic, that means you know a little bit. But some like no prior experience and advanced, yeah, these two are relatively less. For those students, if you have very good skills, yeah, you can find me, see whether my research projects is suitable for you. Some of you already wrote email to me and had interview. Yeah. Next one. How familiar with your Python? You see here for the Python, the beginner 27, and low experience 11. So if you plus these two, I mean the low experience one and the beginner, so this is already 38. And the next one, the intermediate 46. Yeah. So for those students, I mean, no experience or beginner, yeah, better find a good one. I mean, a good one who is good at the coding. So this one will help you. Next one, other language. Here you can see, yeah, it's really amazing. You see, for you guys, yeah, you see here, SQL 48, great. C plus, almost 50%, yeah, perfect. And the MATLAB 40%, yeah, great jobs. And R 31. Yeah, here I think it's really good. You know quite a bit of things. So overall, you can see for our students, you have the character of data science. I mean, you have relatively intermediate. I mean, the training skills, the 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 data programming skills. Okay, so this one that we have. But for math and stats, yeah, look at this one. 10% agrees or admitted weak, right? And strong 6%. Yeah, this is really good. Yeah, we have 6% students who have confidence, and the basic 40, right? Basic 40. So anyhow, I would not test advanced thing. But if you have interest to do advanced theory, let me know. I have some work for you. Okay. And also intermittent 43. So this one make me feel peaceful. Okay. So then it's safe. I set questions like some theory and some training. Okay. For AI and machine learning, here you see lots of median 16%. You see, 16%. That's why you took this course. Advanced 20%. Yeah. So here, like the ML TensorFlow, PyTorch, yeah, looks good. But also, really you can do that later we can see from your group projects, okay? Next one, like Hurdle and have done small projects. So this one over 60%. So this one make me just look forward to your mini projects later, okay? So this is the overall, okay? I hope this one then make you understand why I teach in this way. Okay, so now let's carry on for set theory. Here for set theory, yeah, this is a mathematical operations at the set level. Yeah, for this kind of thing, we should think. Here, look at this sentence. A basic fundamental group of theorems that governs the rest of mathematics. So how do we understand it? Let's just check one by one. The first one, what is the definition for a set? Yeah, when we mention a set, it is a collection. Yeah, you see, a collection of. So over this page, you see a collection of quite several times, and then distinct objects. If the same thing, so you can only count one time, and then a set can be thought of as a list in Python, but with no repeated objects. So this is the first one, the definition. The second one is about a concept cardinality. You know cardinality in Chinese? Yeah. So this is the word in Chinese, 是. Yeah. So sometimes like in our textbook, it calls magnitude. But I actually I do not like this word magnitude. 数值大小. Usually magnitude means this one. So here cardinality, when I read research paper, almost all paper just use the cardinality. So what does the cardinality mean? the number of elements in the set. Yeah. And denoted by, we use the absolute value signs, right? But this is the cardinality. And why do we have this cardinality? Usually this is caused by sparsity. You know sparsity? 稀疏性. Yeah. So sparsity is a quite popular word nowadays. Yeah, you see right now the data is very tremendous, huge, right? But for example, in a high-dimensional regression situation, so you have a lot of regressors. And then for such regressors, when we measure its influence on the response, we just check what the coefficients, 系数, 回归系数. And for such a coefficients, usually we consider from two aspects. One is about the magnitude, 数值. Yeah, so this magnitude is last one, okay? Last this magnitude. This one just means the 数值, yeah, just like 0.5, 50, etc. The other one just like the sign. Yeah, positive, negative. So this one, like the coefficients measures influence of a regressor on the response, right? So when the magnitudes or the absolute value of the magnitude is very close to zero, so we say such a regressor actually have very, very weak or even no influence on the response. So we then call them the sparsity. Yeah, the sparsity. So for sparsity, you have different definitions. Then in such a sparsity situation, people care about the cardinality. So how many on Earth that will really play the role, okay? Next one, just like empty sets. For empty sets, here is the symbol. For empty sets, that means what? There is no element, a set containing no objects. Yeah, you see data objects, right? But no objects, so it would be empty set. And next one, set membership symbol. Look at this one. How can we see the membership? Like this one used to say an object is a member, right? Belongs to. Or also we have this one. For this one, sometimes people would write in this way. Yeah. And we put the bar over, right? So this one just used to say an object large in a set. Yeah. So this is one we have. And then we have the subset and the superset. So what is the subset? Here is the definition. For two sets S and T, we say S is a subset of T if each element, yeah, you see here we have one sentence, each element is also an element of T, right? So that is omega belongs to S, then we know omega belongs to T because S is a subset of T, right? So this is the subset. And then we have the prop subsets. For prop subsets, that is here S and T is not equal, right? So these two not equal, then prop subsets of T. And here we have the intersection. For intersection, here we use the one here. Intersection, here you either denoted by, you see, here is one event, and here's another event, right? For these two events, here the intersection, that means you have the and relationship. And also you can use the Boolean notation, that is for this place, if you use a hat, yeah, this one just means intersection. And intersection means belong to both, right? Yeah, belong to both. And next one is about the union. For union, just like collection objects that are in either set. For example, you can use what? You can use the word or, war, in A or in B, in S or in T. And also you can use the upper, right? The hat, but here is the upper one. So in this one, so under such a Boolean notation, it means the union part. Yeah. So here for these two. The next one is about the difference. Yeah, for the difference, that means sometimes people just write in this way. in S, but lots in T, right? Yeah, see this one? Lots in T, but in S, right? Lots in T means what? Lots in T just means in T complement set. So that's why here you may also write the intersection, but this one would be complement set. Yeah, so this one that we have. And then next one, figure 3.3, set difference. Yeah, like here is the one. Next one, Yaccard measure. So for this Yaccard measure, here is a definition. The magnitude or just like cardinality, right? Yeah, cardinality. The cardinality of the intersection of two sets divided by the magnitude of the union of the two sets. So this one just tells you what? Yeah, you see, here is A, here is B. So here we have A and B, right? And then for the middle parts, yeah, look at this one. Here I just use the green color. Yeah, so this one would be your A intersection B. But for A union B, that means in A, but lots in B, and in B, but lots in A, right? So here we have the three parts. And here, attention, in such a situation, the Jacobian measure would be the ratio. And here for this ratio, above intersection, the below is the union. Yeah. So here you must understand, sometimes we call it the Jaccard, the similarity. And here gives a meaning. For this Jaccard similarity, it quantify 量化 similarities between elements represented with sets. And then here, for such the Yaccard measure, you would see that when it closer to 0, so people are more dissimilar, 不像, right? But when the measure is closer to 1, then people are considered similar to each other. So this one is a similarity measurement. And the similarity, dissimilarity is something that people use widely in machine learning. Next one is about the one application. Yeah, for this application example, yeah, here just like, yeah, if we give you two sets and then you can check the formula and do a calculation, right? And then finally, here you can see, take a look at Yaccard measure. Yeah, we can define the similarity between the two. And the number is 0.2 close to 0, right? So this one tells you what? This one tells you actually the people winning this group is dissimilar, not alike, right? So this one just tells you. And also here comes out some the Python calculation. Like if you have two sets, and then how can you do some the calculation? Okay, yeah. Here is the one I just want you to read such pound rotation. Yeah, this one for my research team, they particularly write the notes for you so that when you read it, you can do some self-study. So later you see here, you have the results, like here you have the Yaccard and the return. Yeah, you see? So this is the one how we have it. Okay. Here we then can do some summary. For this summary here, you see we learn quite a few fundamental concepts. But then we have to go to more about the set theory. Here I used my teaching notes several years ago, maybe not several years ago, almost 7 years ago. There I referred to quite a few books covering engineering, finance, and etc. And here we show some preliminary thing. Here I just want to introduce to you guys. So first of all, let's look at the probability. Yeah, this is the foundation of data science. But if we want to do probability thing, we need to know set theory and the set operation. So here we can see some laws of set theory. Here we just pick up the memory. And the next one, here we must grasp axioms of probability. Without axioms of probability, you can hardly to say data science. Yeah. 这个概率公理可以说是一个基石。Yeah. So here, then we introduce three important results: conditional probability, like multiplication rule, Bayes rule, the law of total probability. But here, attention. Later, when we introduce the three rules, you would find mathematically they are saying the same thing. But when you express in different way, the meaning are different. Let's just check one by one. Before we go ahead, here, first of all, I lead you guys to learn or pick up the memory about three concepts. The first one is about sample space, 样本空间. The second one, event, 事件. The third one, experiment, 试验. Yeah. So these three are important. For sample space, it is the set of all possible outcomes. Yeah. For example, if you roll a die, so this is the results. Possibly number 1, number 2, until number 6 would turn up, right? So this is our sample space. It means a collection of outcomes if you do something, right? If you do an experiment, yeah. And then for the events, it would be any subset of S, the sample space. For example, here is one event A. If you look at this one, it tells you what? It tells you if you toss a die or if you roll a die, all even number would be up, right? So this is the sub-events. And then next one, this one tells you if you roll a die, so the up number should be less than 4, right? And also here, each one are called sets in a set theory. Yeah. So these are three fundamental concepts you should always keep in mind. 样本空间、事件和试验. Okay. And then next one here is about three operations in set theory. Union, intersection, and complement. And here for this complement, as I mentioned, you may write in this way A prime, but meanwhile you can use A complement. Yeah, this one just shows you. And then next one, empty sets. For empty sets, this one, if intersection, if here we have an intersection, it's an empty set. So we say these two sets would be mutually exclusive, 互不相交, or just like a disjoint, 不相交. Yeah. So this is some fundamental concepts, right? Yeah, maybe 3 years ago you learned it, or 2 years ago you learned it. Yeah. And then next one is about the laws of set theory. Yeah, this one shows you the operation of set, right? And then you use what? You use the union, intersection, and complement, right? So here I particularly want you guys to see the De Morgan law. For this De Morgan law, you can see the complement set of union becomes what? Intersection. Or just like complement of the intersection becomes a union. Yeah, this is useful. For other, it looks like union, you can exchange, right? And intersection exchange, here you can exchange. But for this one, just like you take some multiplier, yeah. So this is something you guys should be very familiar with. And then next one, let's go to the cornerstone. We call this one the cornerstone of data science, yeah. 和概率公理, yeah. So what does axioms of probability? It means for such facts, you accept this. You don't need to prove it is right. Yeah. You have to accept it. If you do not accept this, then the whole system will be collapsed. Yeah. So here it tells you, number one, for probability, it should be what? It should be a chance, right? Yeah, this one tells you probability of a set or probability of an event. Remember, Here A, you may say event or just like a set. So a probability should be a chance. Chance means what? Chance just means it may happen or it may not happen, right? Yeah, it may happen or it may not happen. And it may happen with highly possibly or rarely impossible, right? For example, if you look out the window and you say, oh, seems like, yeah, it's cloudy. So you feel it may rain, right? So here you may say, 80% possibly I feel it will rain. So you take umbrella with you, right? But when you look out the window, yeah, you see the sky is high, blue, and you say, rarely it will rain, maybe 10%, 5%. So you just empty your hands, right? So here 0 and 1, closer to 1, highly possibly. And here then we have some special thing like with probability 1. That means what? If, oh, sorry. Yeah. Here, if the probability of an event is exactly 1, we say with probability 1, 概率1成立, right? With probability 1, some event occurs. But here we also have some other thing like A dot E dot. Almost everywhere. Yeah, why do we say almost everywhere? On the other hand, you see the complement set would be 0, right? So this one tells you A complement is a 0 measure set. Yeah, it's a 0 measure set, 零测记, right? So that means it is only on a 0 measure set it may occur, right? So we may say almost everywhere it will occur, 就是几乎到处发生 except a 0 measure set, 去掉一个零测记, right? And also sometimes people use the A dot S dot, almost surely. Yeah, for example, you say, hey, let's catch up later. You say, sure, right? Yeah, so here, just like almost surely, yeah. So here, the first one, it should be a chance. So because it's a chance, you have some other words. For example, people say the possibility, and it could also be what? Like the probability, right? Yeah, besides probability, you have also like the, I mean, more words, uncertainty, uncertain. Yeah, uncertainty. And also you have something like random, like stochastic, right? Yeah, a lot of such words. Yeah. So this is the first one. And then the next one, over the sample space, the probability measure would be 1. Yeah. So for this one, you can see we have the constraints, right? And then that's why probability is a branch of mathematics. And probability is the foundation of statistics. Yeah, because if you look at the pure math, seems like everything, yeah, you can see nothing, right? But for probability, it gives a structure. If you have a thing in structure, so usually it's easier to handle, right? So here for probability, we give a structure, we give a probability measure, and then this one help us reduce the mathematical difficulty, and then we can handle more. And next one, here we have mutually exclusive. Remember this one we say disjoint, right? 不相交的. If we have the disjoint event, so their union would be what? Would be the summation of each probability of the event, right? So this is the axioms. Yeah, we call this one the axioms of probability, 概率公理. Yeah. So relying on it, we have the data science gradually. And here comes some rules of probability. You know, such rules of probability means what? You have a probability measure Yeah. Prob probability measure. Yeah, you have a probability measure on an event, right? Or say on a random event. Yeah, this is the thing that we have. So here we have a probability measure is on the set. So this one tells you what? This one tells you actually you use a PA complement set equals 1. So you have this one, right? And next one, the empty set, the probability would be 0. And a subset, the probability should be less. And the union would be exactly 1 to minus 3 and more things. Like this one, here I want to explain this one. For this one, you actually have A transpose intersection B and plus A intersection B, and then this one would be your PB, right? How do we have it? Here, it actually has something like probability B intersection the whole, the sample space, right? And then for this S, you know, it would be A transpose union A. So that's why we have it. Yeah, this is some fundamental thing about the set theory, the probability. You guys must know that. If you do not know that, that would be troublesome. Then this course may be not suitable for you then, okay? Next one, here's something really important. And then each one means some new branch. Let's see one by one. First of all, conditional probability. Yeah, for this conditional probability, what does it mean? That is, here we say given B set, or just like what? Or just like conditional on B. Yeah, if you have to read this. Given B or conditional on B, for any event A and B, we define probability A given B would be what? Would be a formula here. Yeah, you see? This is important, right? A given B means what? Means you have to consider B is known already. So that's why here for the denominator, we have the probability of B. A given B, so this one should be A intersection of B, right? Only a part that would be involved by B will work, right? A given B, B is known already. So if you try to denote it, so you try to use what? Try to seems like, yeah, you can understand in this way. Let me try to draw a figure. Yeah, you see, this is your A and this is your B, right? So look at this A. So for this A, you can see some parts just belong to what? Some parts just belong to B. Some does not fall into B, right? So then we can see here, sorry. So here we have, yeah, this is the one, right? So now look at this part. So this part just means words, lots in B, right? And in A, right? So we care about what? The parts that would be contributed by B but related to A. So then here for these red parts, this would be exactly A intersection B. And then for the right part here, yeah, you see, yeah, look at this one. So this one just exactly in B, but lost in A, right? So that's why here we have given B. So you just use the B related thing, right? B related thing over the whole B. Because you only know the information about B, right? So when you try to derive something with respect to A, you use your knowledge your known thing about B to handle it. See that? So this is the conditional probability you must grasp. And then it comes out 3 rules. The first one, multiplication rule. If you look at this one, you can see what happens. Is actually we do something like the denominator go to the other parts, right? So that is here for probability of B, it becomes a factor here, right? So this one tells you if you consider A intersection B, then it means you may consider the B possibility and then multiplied by given B the A possibility, right? So we call this one 乘法准则 multiplication rule. And based on this one, you would know something like independence or large independence. Yeah, large independence, we say dependence. So what does this one mean? Here we say, yeah, you see, if you compare the upper and the top bottom, you see, here is something, right? Given B or large, the probability of A is not affected, right? Yeah, so look at this green part, we say A and B are independent, right? Because given B, it does not affect your possibility of A. Yeah, so, and then accordingly, we say A, B, not independent, dependent, or just like independent, we have such one. Yeah, given B or not, yeah, you don't mind, right? Or just another thing like a given B or given the B complements S, your probability for A is still the same, right? So this is intuitively, you understand whether A and B independent. So we call this one multiplication rule. The second one is about art. The second one we call is the Bayes rule. For this Bayes rule, you see which one is of interest. You still care about A intersection B, right? Yeah. And then Bayes rule here, you change the order A and B. Yeah, you see, you know some facts like a given B, what happens? Yeah, look at this one. Here is the one. Yeah, here is the one like given B, right? Yeah, given B, you know the facts. But right now, you just want to know, how about the given A? Yeah, how about the given A? What happens? Yeah, what happened to B? Yeah, here comes the situation. Yeah, if this is the one, what would be the conditional probability? You just change the given parts, right? Yeah, you know, like given A and B. For example, you know something is missing, and then that means given means who might take it away, right? But on the other hand, just like given somebody, what's the probability that person may take that thing? Yeah, that is another story. So that's why we have the Bayes rule. For this Bayes rule is again the conditional probability, but compared to this place, here is A given B. But right now we want to do, how about B given A? So for this B given A, we just know that it could be denoted by what? Here we actually have one more step. According to the conditional probability, it should be probability BA and over PA, right? Yeah, supposedly you should write in this way. But then for the above, yeah, look at, yeah, just look at this place. I mean, this numerator. So we know for this numerator exactly, we have the facts here. Yeah, this is our multiplication rule, right? Yeah, this is our multiplication rule. So based on this rule, you apply into. So this one tells you, you apply the conditional probability and multiplication rule, and then you further write like probability of B and the given B and divided by PA. So Bayes rule is so important. It is a foundation that later, people developed the Bayes statistic, Bayes spirits. And right now, for Bayes spirits, it's very popular in machine learning. You know why the reason? The reason just like if you are given the data, then you can update what you think of or your opinion on a thing. Yeah. For machine learning, so currently people still try to learn from tremendous data and then find out the pattern. So Bayes rule and Bayesian statistic are important. Okay. So here is a more general version. This one tells you if you consider a partition. So partition mutually exclusive. That is word I say partition. That means if you find out any Bij, their intersection would be empty set. And then here you can see something actual is about the R, the rth part, right? So for this rth part given A, and then for every place like you give BR, BR, and here for PA, attention, for these parts, is actually equal to what? It's actually, here you can show PA equals PA intersection the whole sample space. But for this one, it means what? You have A intersection, and then inside it would be the union of BI, right? So this is the way. So that's why finally you have what? Yeah, you have the summation and then A intersection B. Yeah, you know, this one would be exactly like something like P BI. So this one just like some PAI. Is this right? Yeah, I guess we should use the BR and then ABR. Yeah, this one should be right. But for the A, then it would be one set of the parts. Okay. So this is the base law. Next one is about the law of total probability. So this one is exactly the formula we use. Yeah. So here, yeah, you can see I give you the formula here, right? Yeah. So this one, the law of tolerability, you can see is used in the above, yeah, in these parts. So here for A, just like if you given some probability of BI, then you can have the A probability. So we call this one law of total probability, or just like the law of total probability. Sometimes another name would be the law of elimination. So this is the three very fundamental probability theory one must grasp, and it's based on the axiom of probabilities. Okay, and then next one I would introduce the random variable. Yeah, for random variable, because we have multi-background students, so some may never meet such a mathematical definition. Remember, when we mention a random variable x, here we say it's real valued function, a real valued function defined on a sample space with a probability measure. Yeah, so how do I understand that? So here you can see x is a real function. So x actually denotes by x of omega, right? A real valued function. So x is a function defined on a sample space. So that means what? Here for omega, it comes from a sample space. And then with a probability measure, that is, here you can write a probability measure, and then it goes to what? Just like yeah, like you come to some value just between 0 and 1, right? So if you try to translate this sentence, we just do it this way. In more detail, here is the definition. Yeah, look at this one. Cumulative distribution function, CDF. So this one tells you if you have a random variable x, right? You have a random variable, and then you will have what? The CDF. You may even have what? fx. So for this lowercase f, it means what? It might be the probability density function, or it could be probability mass function, right? Depending on just like continuous or just the discrete. Yeah, just relies on it. So, and also you may have more things, for example, like MGF, moment duration function, but whatever, each of them would be 1-to-1. So then it comes a sentence. The sentence says what? For any random variable, once the distribution is given, then you know everything. So why do I say in this way? Yeah, for example, you may consider like expectation. This is the first order moment, right? And then you have what? EX square, or just like what? This is the second order moment. Or just like you have x minus mu x. So this is our centered second order moments, 二阶中心句. Yeah, so here, this one exactly your mu of x, the mean value. And this one exactly, yeah, this one exactly your sigma square, right? Your variance. And also you may have more things like x3, x4, right? Sometimes for this one, people use ex minus mu x3. So when it is symmetric, so this one just becomes a 0 when for a normality distribution, right? So here for the third order moment, the fourth order moment, 三阶距, 四阶距. So this is some characteristic of a random variable, right? If you know the distribution, then you can go to any place. And also like, for example, for a cosine 0.5. So this is a median. Yeah, 中位数. Yeah, so for cosine median, that means what? The probability x less than or equal to cosine 0.5 would be exactly 0.5. That means just like half would be less than cosine 0.5, half would be greater than it. This is the median, right? So here, for median is some similarity to what? To the mean we calculated here. So just remember this sentence. For any random variable, if we know the distribution could be what? The distribution could be any of the formats. Then you know all the things. But if you do not know such distribution, what you can do, you may consider the moment. Yeah, consider is 去. Yeah, so like the order moments. So this one will help you different thing. Like first order moments tells you what? The central tendency, right? For example, in Hong Kong, what would be the mean monthly salary of a family? It's around 20,000, right? And if you look at the median, you know what is the value then? Roughly 40,000. So that's why in Hong Kong, the Gini coefficient is very high. Yeah, because here the mean and the median just deviate much, right? And then for the second order moments, like here, you then know the variation. You know, variation is really important. For example, how to measure the variation. You ask me, Catherine, what's your age? How old are you? So I say, I am between 8 to 80. So you don't know anything about my age, right? Yeah, because 8 to 80, this is always right. So such answer has too much variation. So low information is given. But if I tell you, I am between 35 to 45, so it's easy for you to guess my age, right? Because here you see the interval only 10. So for you at most, you made 10 mistake, you can always guess the age, right? Yeah, variation very important because it measures the precision of some approximation. And also like the third order moment, this one tells you the kurtosis, like, and also like first order, the skewness, right? Skewness, kurtosis. Oh, sorry, this one should change. The third order just means the skewness. That means last metric. So skew to left, skew to right. And then for fourth order, it's the kurtosis, just like whether the curve distribution very flat or just very sharp. Yeah. So this is something we just want to introduce. And next week, we will introduce more, and we gradually go to the point estimation, interval estimation, and test. Yeah. Let's stop here. Thank you, guys. So 32, we will start. Okay.